the decimal numbers na 1.8, 3.8.
Yes, correct.
Yeah, that I have a little bit confusion, sir.
Which question? I'll show you the question. You can tell me. First, I'll solve the application problem.
Okay,
Then
okay,
I'll.
okay. Yeah,
Okay.
sir. Yeah.
Okay. Naseem, any problem you have a issue with any of the solutions, or you want me to solve any of the problems? Naseem, are you there? All right. Okay, fine. So I'll see the problem first. Okay, first I'll solve the second assignment application problem. I have that open. Then I'll see the first assignment problem. I'll write down the question first. So basically there are three statements, right? Just a second. Okay. So there are basically they have given three statements, no? So first
Yes.
statement is Sachin, Virat, and Rahul have scored a total of 40,000 runs. The statement 2 says if Rahul had scored 20% more runs, if Rahul had scored 20% more runs, he would have scored as many runs as Virat. And the third statement says if Sachin had scored 2000 more runs, Virat had hello. Virat had scored 25% more runs and Rahul had scored 50% more runs, then total runs would be 50,000, right? Okay. So here they have actually given you three statements. From that, first you have to form the equations. The three equations you have to form, and from that you have to answer the remaining questions. Okay. So it is also told that okay. So there are three variables here, S, V, and R. S will be the runs scored by Sachin, V will be the runs scored by Virat, and R will be the runs scored by Rahul. Okay. So the first statement they're telling Sachin, Virat, and Rahul have scored total of 40,000 runs. So the first equation will be S plus V plus R equal to 40,000. This is the first equation. The second statement they're telling, if Rahul had scored 20% more runs, he would have scored as many runs as Virat. So now Rahul has scored R runs, right? So Virat's run will be equal to Rahul into 1 plus 20 by 100. So basically it will be V equal to 1.2 R. This is my second equation. Third statement they're telling, if Sachin had scored 20,000 more runs, so S plus 20,000, and Virat had scored 25% more runs, so 1.25 times Virat's run, plus Rahul had scored 50% more runs, so it is 1.5 R, that will be equal to 50,000. So if you simplify it, S plus 1.25 V, 1.5 R equal to 30,000. This is my third equation. So these are the three equations, right? Is it clear, Archana? The three equations,
Yes,
how
sir.
did I get?
Yes, sir.
Oh, okay. This is the first, this is the second equation, and this is the third equation. So three equations. Now I'll see the questions, what they have told. So first question is, please report the matrix A. Matrix A is of the form they have told, right? So
Yes, sir.
I'll just copy down the equations. First equation, S plus V plus R is equal to 40,000. This is number one. Second is V equal to 1.2 R. Means I can write it like this. V minus 1.2 R equals to 0. This is my second equation. And the third equation is S plus 1.25 V plus 1.5 R equal to 30,000. S plus 1.25 V, 1.5 R equals to 30,000. So now if you just form the matrix, I'll tell it A dash. Okay. So it is 1, 1, 1, 0, 1, minus 1.2, 1, 1.25, 1.5. So this is your A. Sorry, this is not A dash, this is A. So it is told that A is of the form 1, 1, 1, A21, A22, A23, A31, A32, A33. So this matrix is of that form only. So this is the matrix A. This is the answer to the first question. Okay. This first question answer. Is it clear? Any doubts?
No, sir.
Okay. So the second question they are telling, okay, please report the vector V. Okay, 1 second. Okay, so here I have done one mistake. I think this is 20,000, 2,000, not 20,000, right? So this is 2,000. So this will be 48,000. So my B vector means the right hand side vector, right? This is 48. So what will be B? Can you tell Archana now from these equations?
Yes, sir.
Yeah, tell me.
40,000.
Huh?
Next is 0.
Correct.
Next is 48,000.
So these are the two questions asked, right? There is no more
Yes, sir.
question from.
Yeah.
Okay, so it's clear, right? Just there are the
Yeah.
three
Yes,
statements.
sir.
You have to translate them into the equations, and then you can easily solve them.
Okay, 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 sir.
Okay, and the first assignment you asked, right? First assignment I'll see. I'll see the question once. There is no application problem in the first assignment. I cannot find it. Which question can you tell me?
Yeah, okay, sir. Okay, sir. We have only in the week 2 assignment we have application, sir. Sorry, sir.
Yes.
Yes, sir.
Okay.
Sir, that one more, sir. That one,
Which one? The which question can you tell me?
sir, in the week 2, the first question, sir.
1 second. So it is which question? This one, no? The three equations are given, and then you have to form the augmented matrix. All those. That one you're asking?
Yeah, yes, sir. That 5 minus 1, 2, 9,
That one.
1, 3.8. That one, sir.
So that is very clear, no? The three equations are given. You have to just write the in the form of the matrix. Where is the
Uh,
doubt?
yeah, next is we have to find the x, y, and z values using
Okay, using Gaussian elimination, no?
yeah,
Oh,
yes, sir. Gauss elimination.
okay, okay. I'll do that.
Here we have a decimal, no, sir. Little bit confusion. That's it, sir.
Ha ha. I'll write down the equations first. 5x minus 3y plus 2z equals to 9. X plus 3.8y minus 1 8.0. 2x plus 2y minus 5z equal to 7. First, second, third. So first is you have to form the augmented matrix, right?
Yes, sir.
So A slash B is 5 minus 3, 2, 9, 1, 3.8 minus 1.80, 2, 2 minus 5 and 7. This is clear, right?
Yes, sir. This one is
So
clear.
next question is, please perform the first step of Gauss elimination where the first row is used to convert A21 and A31 to 0. The resulting matrix is of the form. Okay. First step you have to perform. So first step, what you have to do, you have to convert it into these two elements. You have to convert to 0, right?
Yes, sir.
A21 means this element,
And
and this is the
A31.
so
Yes.
what will we do? First step we will write R2 equal to R2 plus A21 into R1. What is A21? A21 is, sorry, this is alpha. Alpha 21. What is alpha 21? Minus A21 by A11, right? So how
Yes, sir.
much is alpha 21? Can you tell me?
A21 is minus 1, A11 is minus 1 by 5.
Yes. So it is minus 1 by 5.
Yes, sir.
And okay, so first step we'll do this one. 5 minus 3, 2, 9. This one is 0, 3.8. So 3.8 minus of minus 1 by 5. So it is 1 by 5 into minus 3. 3.8 minus 3 by 5 means 0.6. So it is 3.2. 1 second. Just a second. Sorry. This is minus 1. 1. So it is minus 1, right?
Yes, sir. That is minus 1.
Yeah, that one I did mistake. Sorry, 1 second. So it is basically how much? 3.8. Alpha 21 is minus 1 by 5, right? Minus 1 by 5 into R1 is minus 3.8 plus 0.2 is equal to 4. This one is minus 1.8 minus 1 by 5, 2. Minus 1.8 minus 0.4. So it is minus 2.2. Minus 2.2. And this is 0 minus 9 by 5. So it is minus 1.8. And this step only we will do. Okay, let me write this one. 2, 2 minus 5, 7. So next step, what you have to do? Can you tell me the next step? Which one I have to make 0?
Sir,
This one.
A31.
So what will be the equation? R3 equal to
R3 plus Alpha
R3,
3,
alpha 3 1, R1. So
alpha
what is
3 1,
alpha
yeah.
3 1?
Minus A31 divided by,
A 1 1, right?
yes, sir.
Minus 2 by 5. So this will be finally 5 minus 1, 2, 9, 0, 4 minus 2.2 minus 1.8, 2 minus 2, 0. This will be your 2 minus 2 by 5 into minus 1, 2 plus 2.4. This is 2.4. This will be minus 5 minus 4 by 5 minus 5.8. 7 minus 18 by 5. It's 3.6. So it will be 3 point. This is after the first step. Clear?
Yes, sir.
So decimal, there is nothing different. Just you have to do the calculations properly, nothing else.
Yeah, yes, sir. Yes, sir.
Then you have another question from this. So it is told perform one more row operation with row 2 as the pivot row and report the this one. So in the next step, what we do, we'll make
We have
which
to do A32 equal to 0.
correct. So this one we have to make 0, right?
Yes, sir.
So I'll copy the matrix. 5 minus 1, 2, 9, 0, 4 minus 2.2 minus 1.8. 0, 2.4 minus 5.8, 3 point. So this one you have to make 0.
Yes, sir.
So R3 will be equal to R3. And it is told you have to take row 2 as the pivot element, right?
Yes, sir.
So alpha 32 R2. What is alpha 32? Alpha 32 is minus A32 by A22. It is minus 2.4 by 4. So it is how much? Minus 0.6. So we get 5 minus 1, 2, 9, 0, 4 minus 2.2 minus 1.8. So this will be 0, 0, 0. This will be 0 and this will be minus 5.8 minus 0.6 into 2.2 minus 5.8 minus 22, 6, 13.2. 1 second. Minus 8.8. I'll use the calculator one set. Minus 5.8 plus minus, right? Plus 13 point. Some calculation mistake I'm doing, I think. Is 1.32. So it is minus 5.8 plus 1. So it is minus 4.48. And this is this is 3.4 minus 0.6 to minus 1.8. 0.6 into 1.8 is 1.08. 3.45. So this is the final answer. Okay,
Yes, sir. Yes, sir.
clear?
Yes, sir. Sir, this is
Okay.
the row operation R2, R3 are the standard formulas, right? R2 is equal to
Yes,
R2
yes,
plus alpha. For every problem, we have to use these formulas, R2 and
yes, yes,
R3.
yes.
Yeah, okay, sir. Thank you. Thank you, sir.
Okay.
Yes.
Fine. Anyone else is there? Nasim, you have any problem with any of the assignment questions? Anything doubts?
No, no, I solved the question, so I didn't find any difficulty.
Okay, fine. Okay, so we'll start today's class. Okay.
Yes. Yes, sir.
So I'll give a quick recap of what I had discussed in the last class. Then I'll go to today's class. Okay. So basically, last class we were talking about solving linear equations, right? So in solving linear equations, we first talked about different methods we talked about. First was we talked about the row picture and the column pictures, how to simplify any linear equation into a row picture and column picture, what is the importance of those. We from any given two linear equations, how to interpret them, how to plot them on the graphical, how to graphically rather solve them. We dealt with all those things. Then we went to find out the row picture and the column picture. From that, we saw from column picture, if we find the column picture of a particular system of linear equations, then intuitively we can solve some of the equations from the graphical or the vector approach, right? Then we concluded that in the 2D we can intuitively we can solve using the graphical approach, but once the equations are of in the 3D plane, right? So if there are three unknowns and three equations, basically each equation represents a plane. So it's you have to draw it on a 3D plane and then you have to imagine, which is much more difficult than the 2D or the linear case. So we have some different methods or different techniques for solving those 3D equations. So then we talked about when to Gaussian elimination and back substitution. So in Gaussian elimination, we talked about and back substitution, we basically talked about decomposing the matrix, any matrix into a lower triangular matrix and an upper triangular matrix, right? And from that, we found out how we can convert by elimination purpose, how we can convert any system of equations to a lower triangular matrix and an upper triangular matrix. And in the Gaussian elimination and back substitution. So the first step is you have to convert it into an upper triangular matrix. Basically, the A21 for a 3 cross 3 system, basically you have to convert all the elements below the principal diagonal. So this is your principal. So just remember this principle, right? So this is your principal diagonal, right? If this is your principal diagonal, all elements below this should be zero for an upper triangular matrix. So your job will be to make all the elements below this lower, the principal diagonal equal to zero. So once you make equal to zero by Gaussian elimination, two steps you have to perform and for a 3 cross 3 system, obviously, and then you will get the upper triangular matrix. So here you have got, this is the upper triangular matrix. So once you get the upper triangular matrix, now you back substitute, right? So you go from the bottom to the top. What do you mean by that? You have this is my A matrix, this is my X matrix, which is X, Y, Z, the unknown matrix, and then we have the B matrix, right? 8, 4, and 6. So from that, the last, we substitute the last equation. So it basically gives 2Z equals to 6. So from that, we get Z is equal to 3. Once you get Z, then you go to the next row. So there is a second row. So there you substitute this value of Z and find out Y. Once you get Y and Z, you go to the first row. There's a topmost row where you substitute these Y and Z values and get the value of X. So this is the basic principle of backward substitution. Then we went to LU decomposition matrix where we basically decompose any matrix into an L and a U, that is a lower triangular matrix and an upper triangular matrix. And from that, we found out how we can get the solution. You can just go through these notes if you miss the lecture, or the recording is also available with you. So this was all what we discussed in the last class. Then we solved about, then we found out how we can find the rank of a matrix and what are the three different cases we solved. That is when you have an unique solution, when you don't have any solution, when you have infinite number of solutions. So from the rank of the matrix, you can find out. So these were the things which we had done, right? So now today we will just continue from here only. First, we will see how to geometrically interpret, how to geometrically solve any linear system of linear equations. So if you have any doubt, you can stop me in between, okay? Geometrical interpretation. First, I will do in 2D, then we will move to 3D, right? 2D, that is two unknowns. So suppose we basically saw three cases, right? So case one was unique solution exists. So what do you mean by unique solution exists? In the graphical thing, we have the coordinate system, the x and the y axis, right? This is my x-axis, this is my y-axis. So unique solution means basically, suppose there are two equations, right? X plus y equals to 10 and x minus y equals to 2. So if you plot these two equations, I told in the last class how to plot two equations, right? So x plus y equals to 10 means this is the first equation, this is the second equation. So we can write the first equation as x by 10 plus y by 10 equals to 1. And second equation we can write x by 1 plus x by 2 plus y by minus 2 equals to 1. So if you get any linear equation, just convert it into x by a plus y by b equals to 1, and then you can plot. So the denominator of x is the intercept of x, and denominator of y, that is b, is the intercept of y. So x by 10 plus y by 10 equals to 1 will look like this. Approximately it will look like this. And x by 2 plus, sorry, 1 second. And this one, x by 2 plus y by minus 2, right? X is 2 approximately here, y is 2. So it is somewhere like this. So you get an unique intersection point, that is a single point, this one, where these two lines intersect. So this is a unique solution. These two lines, two equations have a unique solution. That is the two lines intersect at a particular point, only one point. So that's why we say that a unique solution exists. Okay. So if you solve these two equations, you will get the coordinates of this point. So it is basically 6, 4. So this is a unique solution, right? Is it clear?
Yes, sir.
Okay. So now second case was basically no solution. So can you tell me when can two equations have when can two equations have no solutions? Means in the geometrical approach, can you tell me how we can interpret that one? Any idea? So when do you think the two straight lines do not intersect? What are those lines called? Two straight lines which do not intersect at any point.
Parallel, they are
Parallel.
parallel lines.
So that is the case. So suppose you have x plus y equals to 4 and you have 1 second. Okay. And you have x plus y equals to 5. Do these two equations have any solution? Means you cannot solve these equations, right? Why you cannot solve? Because these two lines are parallel, that is their slope is equal. So x plus y equals to 4 will look like this, and x plus y equals to 5 will be a parallel line, right? Sorry. Is it clear? So this is x plus y equals to 4, the red line, and x plus y equals to 5. These are two parallel lines. So they will never intersect. So basically then we have no solution, right? Okay. So the third case is, case 3 is basically when you have infinite number of solutions. So when do you think two lines can have infinite number of intersection points? Suppose you have two equations like this. One is x plus y equals to 4. Another is 2x plus 2y equals to 8. So what do you think will be the solution for this? How will the two lines look? At least that much you tell me. X plus y equals to 4 is this one, right? How will 2x plus 2y equals to 8 look like? Any idea?
It will overlap on the same curve.
Yes, correct. So x plus y equals to 4 is nothing but 2x plus 2y equals to 8. So it is the same line, right? So it will be overlapping on the same curve. So sorry, it will be on the same curve. Just to differentiate, I am drawing it a little different. This is the same curve. So there are infinite number of intersection points, right? So there are infinite solutions. Overlapping. So these are the three cases and their geometric interpretations. Clear, right? For the 2D case. So there are three cases I have dealt with. So next you have, if we just try to imagine in the 3D scenario. So 3D scenario, it can be different, right? So I cannot, it will be difficult to draw. I'll show you with the three different pens. You can understand. Suppose you have three planes, right? So this is one plane. This is another plane. One second. So there are three planes, okay? Three different things I have taken. Three planes. You can see.
Yeah, we can
Yes,
see.
yes, sir.
Okay. So suppose we have three planes like this, arranged in this way. So these are three different planes which are parallel to each other. So they will not have any solution because they're not intersecting anywhere, right?
Yeah. Yes, sir.
So now there can be different combinations. Suppose you have like this. These two planes are intersecting, whereas this is like this, right? So here there are infinite number of solutions for this case because this plane is intersecting with this other plane. So it is intersecting at a line. So basically you will have all solutions on this line, that is this intersection line, right? This plane and this plane are intersecting like this, and this plane is ahead of it. So it is not intersecting. However, there is an intersection point here, not a point, rather a line. So it will have infinite number of solutions. Unique solution will be only when it is difficult here to show you. So these two planes are intersecting like this. If a third plane goes inside this plane, if a third, so here these two planes are intersecting at a particular straight line, right? This straight line. So you have to get another plane such that this straight, it intersects with this straight line at a particular point. So it will be only when it is inside this plane. So that will only case that will be when you have a unique solution for this. Fine, is it clear?
Yes, sir.
You have to just imagine this thing, so it will be clear. So these were the geometrical interpretations. Any doubts?
No, sir.
Okay. So now we will move to some of the iterative techniques.
Yes.
Iterative techniques for solving linear equations. So here you have basically two different techniques. First one is Jacobi method, and the second one is Gauss-Seidel method. So both these methods are basically used to solve Ax equal to B, right? Okay. So first we will look into Jacobi method. Okay. So Jacobi method basically. So suppose you have three equations, right? I'll take a problem and I'll describe the algorithm, then it will be clear to you. First equation is 2x plus y equals to 1. You have x plus 2y plus z equals to 2. Then you have y plus z equals to 4. These are the three equations you have to solve. So first is we have to form the A matrix. A matrix is 2, 1, 0, 1, 2, 1, 2, 1, 0, 1, 1. Okay, this is my A matrix. Then just copy down these equations again. First one is 2x plus y equals to 1. Then you have x plus 2y plus z equals to 2. And y plus z equals to 4. Okay. First, second, third. So here the thing is first step. Okay. First iteration. Iteration number 1. That is first iteration. So what you have to do is first you find out from the first equation, find out x. What is x? 1 minus y by 2. Is it correct? So here we will write that is the first iteration. So it is the 0th step. So we'll write x of 0. Sorry, x of 1. And this is your y of 0. So the initial value will also be given to you, which is 1, 2, 1. So for any problem in the iterative techniques, the initial solution, the initial value of the problems will be given to you, right? So x of 0 is given to be 1, 2, 1. So x of 1 from this equation, first equation, we are getting x equal to 1 minus y by 2. And in the from the second equation, we will find out what is y. What is y? Y of 1 equal to 2 minus x minus z by 2. So this is 0. X of 0, z of 0. From the third equation, we will find out z of 1, which is 4 minus y of 0. So here what we are doing is, at the first step, we are doing, okay. So 1 minus y of 0 is 2 by 2. So it is minus 0.5. Can you tell me what will be x of 0 and z of 0? What are the values? Archana, can you tell me?
Y of 1 will be 0 and Z of 1 will be 3, not 3, 2.
Correct.
Yes, sir.
Archana, are you there? Did you get
Yeah,
it?
yeah, yeah. Yes, sir. Yes, sir. Y of
Okay.
1 is equal to 0, Z of 1 is equal to 2.
And in the step 2, what we will do is x of 2 will be equal to 1 minus y of 1 by 2. So
This is
how much
second
will,
dimensional.
what is y of 1? Can you tell me what is y of 2 then? Hello, am I audible?
Yes, sir.
Can you tell me the expression for y of 2?
Sir, that is 2 minus x1 minus z1 divided by 2.
So what are the values? Can you substitute and tell? 2 minus what is x1?
x1 is minus 0.5
And z1?
and z1 is 2.
So it will be 0.25. Correct.
Yes, sir.
And then z of 2 is 4 minus y of 2, right? 4 minus 0.25. So these are the values which you have obtained for x, y, and z after 2 iterations. So you can see here for any iterative technique, when do we stop? Any idea? When do we stop our calculations? We stop our calculation once the previous step value and the next step value are almost equal, right? When it converges to a particular value. So here x is at the first step, x is minus 0.5. Second step, it is 0.5. So there is a huge difference, right? Y at the first step is 0, second step it is 0.25. Z at the first step is 2 and Z at the second step is 3.75. Okay.
Hello.
So now you have to continue these steps. Yes.
I couldn't understand that a step to the formula for means second iteration of z. It should be 4 minus y of 1.
Yes, yes, correct. Sorry. I wrote this one wrong. It is 4 minus y of 1. Sorry. So it is 4, 4, right?
Answer is 4. Yes, sir.
Yes, yes. 4, no, 1 second. Okay. So we have to continue these steps. So what was 1 second now? Okay. So now, if we do this, we'll see that even after fourth or fifth step, the result is not converging. So basically, we have to do at least 40 to 50 steps, which is not possible in using the hand calculations. So what I have done is I have written a MATLAB code for you. From that, you can see how many iterations are required for this. Are you familiar with any programming language or MATLAB, anything?
No, sir.
Okay.
I
Okay.
have heard
Fine.
of MATLAB, but I don't use it.
Okay. 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 No issues. I'll show it. I'll just share my screen. You can tell me whether is my screen visible, the MATLAB screen.
No, sir.
No, no, it's not visible.
1 second. Now is it visible?
Yeah, it's now visible.
Okay. So here, MATLAB, you don't need to know. I'll just tell you how the solution will look like. Okay. So basically, this is Jacobi method, right? So you can see here the plot you're able to see.
Yeah, we can see it.
Oh, just a second, I'll make it just bigger. So these are the different iterations. So x-axis is the number of iterations, right? And y-axis is the value of x. So you can see here at the first iteration, that is the leftmost value if you see in the graph. So it is around minus 0.5. Okay, so from that it is basically oscillating, and then gradually as the number of iterations increase to around 38 to 40, we can see it is converging to a particular value. So which is 3. So 3 is the exact value. If you solve these three equations, you will get x equal to 3. So using the Jacobi method, you can see that it is oscillating, and then so the initial value of x was given to be 1. So the leftmost value you can see here, it is 1. From that, in the first iteration, it dropped to minus 0.5. Then again it was 0.5. Then again if we do, you can verify these values, and you can see gradually after 40 iterations it is converging to a particular value. So this is for x. Similarly, we can just do for y also. So this is for y. This is the plot of y. So y was initially 2, then it was around then it was 0. Then in the second iteration, it was around 0.25. Then gradually it decreased, and the value has converged to minus 5. So the actual value is minus 5 for y. And similarly, we can also do it for x3, that is z. Here also z, you can see it has initially it was 0, it was 1, then it gradually increased, and it has converged to 9. So the exact solution is 3, minus 5 and 9 for x, y and z. So using MATLAB, or simply you can do it in the Excel sheet also. You can just take an Excel sheet, and these iterative equations I have written, right? X of 1 equal to 1 minus y of 0 by 2. Y of 1 is 2 minus x0 minus z0 by 2. And then you can easily do it yourself and check what are the different values. So if I show you the different values, you will understand. 1 second. So these are the different values of x. Can you see the screen?
Yes, sir.
So the first
Yes,
value of
yes.
x is 1. Initially it was given as 1, right? Then in the
Yes, sir.
second iteration it is minus 0.5. Third iteration it is 0.5. Then again if you do like this, you will get 0.375, 1.125, like this it will go on. And at the last around for 38th step, you are seeing it is around 2.9803. And the previous one is 2.9812. So almost we can say it has converged. Similarly, just a second, I will show for. So these are the values of y. So the second row you can see, first it was 2, then 0, then 0.25, minus 1.25, and gradually it converged. If you see around 38th step, it is around minus 4.97. Similarly for Z also you can see here. Is this thing clear?
Yes, sir. Sir, but
Yeah,
in the exam we have to do it in the
No, they will
calculator.
not ask you for the final solution in the exam. They will ask you around first step or second step what is the
The
value.
third iteration, sir. Up to
Ah,
x3 and x5.
yes. No, no. Maybe they will ask you for up to first or second iteration maximum,
No,
not
sir.
more.
In the week, no. In the week 3 assignment, they were asked for x5 up to
Then you
x5.
have to do around four or five is still okay, right?
Yeah,
So
yeah.
you have to that you have to do. Anything else? Any doubt?
No, sir. This is the standard Jacobi method, right, sir? We have to use
Yes,
the
yes,
same formula for every problem.
yes,
This is
yes, yes.
standard.
Correct.
Yes, sir.
No, basically, see here the question they're asking x of 1, y of 1, z of 1. They're not. Have they asked for 5? Till 3, I
Yes,
can
sir.
see.
Sir, we have here x5, I think.
No, here in the questions you can see. Okay, okay.
Yeah, yes, sir.
Z5 they have asked.
Z5, yes, sir.
Hmm. Okay. Yeah. Any other doubts?
No, sir.
Okay.
I wanted to ask, can you give tell something about MATLAB programming? Means just a bit little introduction.
MATLAB programming. Okay. Once different session I have to then schedule for that. I'll do that. So here I have to complete the thing. No.
Okay, okay, sure, sure.
Okay. So now the screen is visible, right?
Yes, sir.
Okay. So this was about the Jacobi method. So in Jacobi method, what we were doing, just carefully note these equations. In the first step, for calculating x1, y1 and z1, we were using y0, x0 and z0. That is the values of x, y and z in the previous iteration. Similarly, for the second step also, when we were finding x2, y2 and z2, we were using the previous values of x, y and z. That is x1, y1, z1. Okay. So now, just remember this one. So once you do Gauss-Seidel method, this thing will be the difference you have to understand. Second one is Gauss-Seidel method. So in Gauss-Seidel method, what we do is the equations are, I'll take the same equations. First equation is 2x1 plus x2 equals to 1. Second equation is x1 plus 2x2 plus x3 equals to 2. Third equation is x2 plus x3 equals to 4. So now from the first equation, we will find out what is x2. Okay, the first iteration. X2 of 1 is 1 minus x1 of 0 by 2. Similarly, second, x1 of 1 is 1 minus x2 of 0 by 2. Now when we find out x2 of 1 from here, so it is basically 2 minus x1 minus x3 by 2. Now the question is, in the previous Jacobi method, we were using the values of x1, x2, or xy as obtained in the previous iteration. But the difference here is Gauss-Seidel method. What we will do is, we will use the most updated values. Use the most updated values. That is, here we have already found out what is x1 of 1. So when we use x1 in the next step, it will no more be x1 of 0, but it will be x1 of 1. However, x3 we have not found out here in this step. So x3 of 0 we have to use. So this is 1 minus x2 of 0, right? So x of 0 was given to be how much? 1, 2, 1, 2, 1. So it is minus 0.5. How much is this one? Can you tell anyone? What is x2 of 1? Archana, can you tell?
Yes, sir.
What is x2 of 1? Just tell me the values. 2 minus what is x1 of 1?
1.
x1 of 1 is minus 0.5, I have found out, right? x1 of 0 was 1. But here when I am using in Gauss-Seidel method, as I told, we will be using the most updated values. So
Yes.
x1 of 1 we have to use in the first step itself. So it is 2 plus 0.5. x3 of 0 is 1 minus 2. So it is around 0.75. Similarly, can you tell me what is x3 of 1? Nasim, can you tell me?
4 minus 0.75 means 3.25.
So it is 4 minus x3 of 1. x2 of 1, right? So 4 minus 0.75, it is 3.25. So now we'll go to the second step. What will be x1 of 2 now? 1 minus x2 of 2. Sorry, 1 minus x2 of 1 by 2, right? Because x2 of 2 we don't know. So I have to use x2 of 1 only. So it is 0.125. What is x2 of 2? Can you tell anyone? What is x2 of 2? Yes, Archana, you want to tell something? Hello?
Yes, sir.
What is x2 of 2? Are you getting it, or should I explain it once again?
No, sir. No, sir.
It's clear, no? Then tell me what is x2 of 2. Just see the previous step.
Yes, sir. Yes, sir.
So it is 2 minus x1 of 2 minus x3 of 1 by 2. So it will be, if you calculate, it will be minus 0.687. Similarly, x3 of 2 will be equal to 4 minus x2 of 2. That is 4.687. Like this, you have to go on doing. Okay. So similarly, I have also written a MATLAB code for this one. You can, for the Gauss-Seidel method, you can just see this one. The screen is visible.
No, sir.
Oh, no, no, it's not.
Now,
Yes,
It's
sir.
visible.
okay. So this is my Gauss-Seidel thing. Okay. So Gauss-Seidel, if I plot, so here you can see the value of x1, right? So 1 second. So if you plot x1, you can see here in the previous thing, in the Gauss Jacobi method, we saw that it was taking around 40 iterations or 38, 39 iterations. So just by using the updated values, that is in the first step itself, we are not using the previous iteration values, but we are using the most updated values. We have reduced the number of iterations to around half. So here the iterations are around 22, 23. So this is the advantage of the Gauss-Seidel method. That is, it is faster. It will converge to your solution much faster compared to the Jacobi method. Because we are using here the most updated values of x1, x2 and x3 at every step. We are not using the previous iteration values. Is this clear? The difference between Jacobi and Gauss-Seidel method?
Yes, sir.
Yes, we understood.
Okay, so this is the difference between the Jacobi and the Gauss-Seidel method. I'll just write it down and then we'll go to the next topic. So if we just write Jacobi method and if we write Gauss-Seidel here. So here, in order to find out x1 of 1, we are using x2 of 0, x3 of 0. To find out x2 of 1, we are using x1 of 0, x3 of 0. To find out x3 of 1, we are using x2 of 0 and x1 of 0. However, to find out x1 of 1, here we are using x2 of 0 and x3 of 0. In the first step, we'll be using the previous iteration because we don't have the new updated values. However, from the next step, that is x2 of 1, we will be using x1 of 1 and x3 of 0. To find x3 of 1, we will be using x1 of 1 and x2 of 1. So if we generalize this, in order to find out x1 of n, we will be using x2 of n minus 1 here and x3 of n minus 1 here. To find out x2 of n, we'll be using x1 of n minus 1, x3 of n minus 1. To find out x3 of n, we'll be using x2 of n minus 1, x1 of n minus. Similarly, to find out x1 of n here, we will be using x2 of n minus 1 and x3 at n minus 1. However, for x2 of n, we already know what is x1 of n. So is x1 of n, x3 of n minus 1. Here we use both the updated names. Just remember this table. So that will basically give you an idea of what is the difference between your Jacobi method and the Gauss-Seidel method. Is this clear? Any confusion, any doubts? You can tell me.
No, sir.
Clear, right?
Yes, sir.
Nasim, clear?
Yes, clear. Understood.
Okay. So this is the difference between the Jacobi method and the Gauss-Seidel method. So you have understood, right? I've shown you with the MATLAB thing also that if it is not possible in our hand calculations, we can easily see that in Gauss-Seidel method, since we are using the most updated values of the unknown variable, so it is taking less number of iteration or less number of steps to converge. So it is around half of the number of steps that was taken in Jacobi method. In Jacobi method, we are basically using the previous iteration values. So that is the reason why it is a much slower method in terms of convergence compared to the Gauss-Seidel method. Okay. So just take a 5-10 minutes break, then we'll start again. Okay. One more topic is two more topics are left: partial pivoting and Thomas algorithm. We'll do that, and then we'll wind up today's class. Okay, just take a 5 minutes break. I'll come back.
Okay, sure.
Okay, so we'll start. Everyone is here?
Yes, sir.
Okay. Okay, so now we will move to a different topic, which is partial pivoting. So in partial pivoting, so we'll see what is partial pivoting, and we'll see how to solve an equation, how to solve uh, system of equations using the technique of partial pivoting. So we'll take a matrix. So 0.02, 0. I'm taking these problems from the book Linear Algebra by S.K. Gupta. You can see there. Zero, 100, 200. This is your A matrix, and the B matrix is 0.02, 1, 4, 2. So what is the algorithm here? So first step is step 1 is first you have to find the entry in the leftmost column which has largest absolute value. Leftmost column which has largest, and that element or the row corresponding to that element should be the first row. If it is already in the first row, well and fine. If it is not in the first row, you have to exchange that row with the first row, right? So when the entry and the row and make the corresponding so here if you see in the leftmost column, that is the first column, the highest entry is 1, right? It is, and it is in the second row. So basically what you have to do here is this entire row, that is R2, you have to shift to first row, that is exchange R2 and R1. It will go here and this will come here. So here to exchange R1 and R2. What will be my matrix now? It is 1, 2, 1, 0, 0, 2, 0.01, 0, 0, 0. Rest all remains unchanged. 0, 100, 200. Okay. So now a similar process we have to follow like Gaussian elimination. We have to make this element first equal to 0, right? So R2 will be R2 plus alpha 21 R1, where alpha 21 is minus A21 by A11. So it is minus 0.0. So in the Gaussian elimination with full pivoting, what we did is we, without any exchange, we made it an upper triangular matrix. But the difference here is that first here you have to make the first row as the largest row, or the a row with the largest element in the first column. Then you have to do your pivot. Then you have to take your first row as the pivot and then perform the elimination. Okay. So now if you do this, you will get it is 1. We are replacing second row, right? 1 2 1 0 is first row. It will be 0. If you do done the calculation, you can just check 0. This remains same. Now the first step is over. So in the second step, what we do, the same process we will follow. So you find out, first step what we did, we found out what is the largest element in the first column. Second step what we will do is, we will find out what is the, which is the largest element in the second column. In the second column, the largest element is 1. And that should be made the second row, because it is a second step, right? So this row should go here and this row should come here. So basically here we will exchange R2 and R3. It will be 1 2 1 0 0 minus 0.0, sorry, 0 1 2 1 1. Here it will be 0 minus 0.03 minus 0.02 0 0 0 100 200. Now what we do, we make A32 equal to 0, right? So this element has to be made 0 now. So we'll write R3 equal to R3 plus alpha 32 R2. Alpha 32 is minus A32 by A22. So it is 0.03. If we do this one, we will get 1 2 1 0 0 1 2 1 0 0 0.02. 1 second. We'll get 0.04 and this is 0.03 0 0 100 200. Okay, so parallelly we have to do for the right hand side vector also, which I did not do. Sorry, we'll do it here. What was it? 0.0214 200, right? So we exchanged R1 and R2. So it will be 1 0.02 400. Here it will be, which one we did? We changed R2 equal to, first we 1 R2 equal to, so it will be 0.02 minus of minus 0.02 into R1. 1 second, I did some mistake. One second. We did it is 0.02 for 200, then we did this one. 1.4. So it is 104. So now we change it to 1 4 0. Is it 0.04 or 0 minus of, sorry, this is 0. This is 0. So this is 0. 0 1 4 0 800. This is not 200, this is 800. So it is basically 1 0. So it is 1 4 0 800. Is it clear till this step? Any doubt?
Yeah, it's clear.
Okay. So 140,800 we have. So it is 140 plus 0.03 into 40, 0.12, 800. Archana, is this step clear?
Yes, sir. Sir, can you please explain the step 2, sir? That is row 2 and interchanging row 3.
Yes. I'll just complete this and then I'll go
Yeah,
through it
yeah.
once again. Okay.
Okay, sir. Okay, okay.
Okay. So now just 5 more minutes. I'll finish this one. So
Okay.
now what we will do is second step we have completed. So now our job is two steps we have completed. So we'll see the third column. So in the third column, which is the highest element is 100, right? And it should be in the third row. So here we will exchange these two. R3 will be exchanged by R4. R3 will be exchanged by R4. So what we will get is 1, 2, 1, 0, 0, 1, 2, 1, 0, 0, 100, 200. Here we have 0, 0, 0.04, 0.03. And here we have 1, 4, 800, 0.1. So I've exchanged this. Now our job is to make this 100 equal to 0. Sorry, not 100. This is the third step, no? 1 second. Previous step, what we did, we made 3, 2. So we'll make 3, 2, we have made 0. Second, this is the principal diagonal. So all elements below this diagonal should be 0. Already this is 0, all are 0, only this is remaining, right? So here if I see my principal diagonal, just a second now. So here now,
0.04 we have to make it as
this you have to make 0, right?
yes,
So
sir.
what we will do, R4 will be equal to R4 plus alpha 34 into R3, correct? So alpha, sorry, not alpha 34, will represent it. Alpha 43 is minus A43 by A33 is minus 0.0004. If we do this one, 1, 2, 1, 0, 0, 1, 2, 1, 0, 0, 100, 200, will be 0, 0, 0, and this will be minus 0.05, and the right hand side will be 1, 4, 800 minus 0. So now our job is done. All elements below this principal diagonal are 0, right? All these elements are 0. Now your elimination process is done. Now we will use back substitution to solve the equation. Using back substitution. What we'll get? Can you tell the first equation using back substitution? Can you tell what will be the first equation we'll get using back substitution? Naseem?
4.
No, I'm asking the equation.
I forgot. Sorry.
Okay. So just see the last row. So this is x1, x2, x3, x4, right? So it is basically minus 0.05 x4 equals to minus 0.2. From that we can find out x4, that is 4, that Archana correctly told. So what will be the second next equation from the third row?
100x3 plus
Yes.
200x4 is equal to
Yes.
800.
So we'll get x3 equal to 0 from here. Okay. Similarly, from the second row, can you tell me what is the equation?
x2
x2 plus 2x3 plus x4 equal to 4.
From that, we will get x2 also equal to 0. And the first equation is x1 plus 2x2 plus x3 equal to 1. From that, we will find out x1. So your solution is obtained. So I'll go through it once again. Just stop me if you have any doubt. Okay. So here in partial pivoting, what we do is we fix like in Gaussian elimination with full pivoting. What we did is we used to without seeing any maximum element and all, we used to just make the all elements below the principal diagonal of the matrix equal to 0. That is, we just used to convert it to a upper triangular matrix. But here one extra step is there that you have to exchange the rows. So that is the difference only here. So for that, what we do is first step is you have to since you are at the first step, you have to find the entry in the first column which has the highest absolute value. Okay, and make that column that element, that row corresponding to that element as the first row in the first step. Is it clear?
Yes, sir. Sir, if it is
Yes.
in the in R3, if we have a 2
Hmm.
in the first element,
Okay.
we have to exchange that R3 and R1, no?
Then we have to exchange R3 and R1. Correct.
Okay, yeah, yes, sir.
Okay.
Biggest number in the first column.
Biggest absolute number, even if it is negative, don't consider the negative sign. Absolute
Okay,
value you have to see. Okay.
okay, sir. Okay, sir.
Okay. So first step, we have done that one. We have made this 0.1210, that row as the first row. So now the first half of the first step is done. So the second half is you have to make this A21 equal to 0. If you want to make A21 equal to 0 using your normal Gaussian elimination, whatever you do the exactly the same thing here. That is R2 equals to R2 plus alpha 21 into R1. Clear?
Yes, sir.
Clear. Okay. So if you do that one, you will get this matrix 1, 2, 1, 0. This thing you will get. Similarly, also do it for the right hand side vector also. The same thing.
Yes, sir.
So now you have completed the first step. So once you go to the second step, you see the matrix which you have now. You check the second column of that, not the first column. First step, you will check the first column. Second step, you check the second column. What is the highest element in that? Here,
Two
One
is
is
the
the
high.
just a second, just a second. I think mistake is there.
I think 2 is the highest. We have to
No,
change.
no, no. One second. The thing is, one second. Let me see. I think the concept here is a bit different. Since you have performed the operation already on the first row, you have already exchanged that, so that we are not considering here. Okay. One second. Okay, got it. So here in the second step, you don't have to check the highest entry. You have to check the second highest entry. Okay. So that's why we are seeing 1 here as the second highest entry and we exchange R2 and R3. So from that, again, we get this matrix. Again, we eliminate this A32 element. We do the elimination. In the third step also, in the third column, you see the highest element. So there is a confusion regarding this second highest element, right? Just a second. I'll just check this one and I'll get back to you in the next week, okay? So there's a confusion here. Should be 2 is the highest element. So, okay, the concept is clear. Just we have to see why we are not taking the 2 in the second step. I'll check that and get back to you. Is it fine?
Yes, sir. Okay, sir. No problem.
Okay. So now we will move to the next thing, the next algorithm, which is Thomas algorithm for a tridiagonal matrix. Just 1 second. Okay. So here Thomas algorithm for tridiagonal matrix. So anyone of you have idea what is a tridiagonal matrix? Any idea what is a tridiagonal matrix?
No idea.
Okay. So I'll give you an example and then you'll understand what is a tridiagonal matrix. So this is your equation system which is given. So a tridiagonal matrix is a matrix that has non-zero elements only on the main diagonal. And means the elements are the non-zero elements are the elements on the main diagonal and the sub-diagonal, that is the first diagonal below this, and the upper diagonal, that is the first diagonal above the main diagonal, are non-zero. All other elements are zero. I'll show what I am telling. So this is the main diagonal, right? These are all non-zero. Correct. What is the lower diagonal? The lower diagonal is this one. -1, -1, and -1. This is also non-zero. And the upper diagonal, that is this one, this is also non-zero. If this all are non-zero and all of the remaining elements are zero, then it is called a tridiagonal matrix. So this is red one is your main diagonal. This is your lower diagonal or subdiagonal. Subdiagonal. And this is your upper diagonal. Is it clear what is a tridiagonal matrix?
Yes, sir.
Yeah,
Okay. Okay. So to solve this type of matrix equations, we have a specialized algorithm for this, which is known as Thomas algorithm. Okay. So I'll write down, I'll solve this, and step by step I will do, you'll just follow. So in the first step, what we do is we divide the row 1 by A11. Clear? So row 1 we first divide by the pivot element, that is A11 here. What we will get? 1 by 2.04 is minus 0.4900. We have the same thing now, minus 1, 2.04 minus 1, 0, 0 minus 1, 2.04 minus 1, 0 minus 1, 0. Similarly, we do for the RHS also. 40.8 divided by 2.04 is around 20, 0.8, 0.8. Now what we do is similar to elimination process. We make this element equal to 0. So R2 will be R2 plus A21 into R alpha 21 R1. That is R2 plus alpha 21 is -1, right? -1 by -1. So it is basically R2 minus R1. So if we do this, we will get 1 minus 0.4900 augmented matrix. 0, you will get 1.55 here, minus 1, 0, and 20.8. Then you will get 0 minus 1, 2.04 minus 1.8, 0, 0, minus 1, 2.0, 100.8. So the first step is over. In the second step, we divide R2 by A22. So what we will get? 1 minus 0.4900, 0, 1. We'll do the calculation first. So we are dividing this second row, right, by 1.55. So it is 1 divided by 1.55. It is minus 0.6450, and 20.8 divided by 1.55 is 13.419. Are the steps clear to you, or any doubt is there? You can stop me. 0.04, 100.8. So again, next step will be A32 we have to make equal to 0, right? That is, this one we have to make equal to 0. Correct? Sorry, not this one. We have to make R3. 2, 1 we have made. Now, 1 second. We have to make correct. We have to make this element equal to 0. So R3 will be R3 plus minus 1 into R2. Sorry, R3 will be plus R3 plus R2. So what we will get? 1 minus 0.4900 20 0 1 minus 0.6450 13.419. If we add this to 0, this will be 1.395. We'll get minus 1 here. This will be 14.219. Is it? Okay. So then again 0, 0, minus 1, 2.04, 100.8. So now we have to divide R3 by A33, right? Divide. Just check the calculation mistakes. Otherwise, it is maybe some mistakes might be there. Calculation, I'm not sure. I'm doing it here only. So you'll get 1 minus 0.4900 20 get 0 1 minus 0.6450. This will be 13.419. Now, if we divide the second row by A33, right? We are divided. A33 is how much? 1.395. So 0, 0, 1, and this one 0, 0, 1, and this is 1 minus 0.717 is 10.193. 0, 0, minus 1, 2.04. So like this, you have to go on doing again. In the fourth step, we'll divide R4 by A44. Then we'll make this element equal to 0. So similarly, I think there are some calculation mistake I have done. That's why I'll just check it once again. Second, R3 equals to R3 plus R2 equality minus. Correct only. So step 4, if we do. Okay, so here we have not done here yet. Now, which one we have to remove? We have to remove 1 second. This element we have to make 0. So this we have to make 0, right? Is minus 1. So this one will make 0. So R4 will be R4 plus R3, correct? So what we will get? 1 minus 0.4900 20 0 1 6450 13.419 0 1 minus 0.717 10.193 and 0 0 0 2.04 minus 0.717 1.323. This one is 100.8. 8 plus 0.193. So you have got it, right? Just one more step you can do. You can just divide R4 by A44. So why? So the difference here is from the normal Gaussian elimination is every step we are dividing the first with the corresponding diagonal element, right? First step we divided R1 by A11. So why we are doing this? So this is basically helpful when you have a lot of decimal numbers. So your calculation will be much more simpler. Once you divide and get whole numbers, the calculation will be much more simpler. So that's why we are first dividing the entire row by the corresponding element, and then we are doing the elimination. So this is the basic algorithm for Thomas algorithm, and we can just proceed and we can find out the solutions. Is it clear? Any confusion?
I wanted to ask, means basically the main principle is to make the principal diagonal means unity, and below it every element should, we have to make it the zero. That is the
Yes,
main
correct.
principle.
Yes,
Okay,
yes.
okay.
Okay. Any other questions?
And
Any other doubts?
is it
Yes,
for
please.
means 4x4 matrix and higher, means that is I'm asking.
Yes, obviously, tri-diagonal matrix will only exist for more 4 by 4 and higher orders, because we'll in 3 by 3 we will not have this lower diagonal and upper diagonal elements, right?
Yes.
Any other doubts? Any questions? Archana, is it fine?
Yes, sir.
And
Okay.
also one question, just
Yes.
the previous method, that the partial pivoting, it is also for means 4x4 matrix and higher.
Yes, yes. Partial pivoting, just a second. It can be done for 3 by 3 also, I suppose.
Okay, okay.
It is okay. So when is the due date for the third assignment?
It's a 14th, I think. 14th August.
Okay. The next week we will discuss the. If you have any questions, we can discuss the solutions of the third assignment also.
Okay, sure.
Okay. Okay. Fine then. We'll close the session today. We'll meet again next Saturday. Okay. Evening
Okay, sir.
7 o'clock.
Okay, sir. Thank you.
Okay.
Okay.
Fine. Thank you.